Hello everyone, this is the second of a three-part introduction to vectors. We already did lesson number 1 and I'm hoping that you all had a chance to review lesson number 1. This is lesson number 2 and we are hoping to have some fun solving some problems that you would normally see at the CSEC level. Okay, so let us get right to it. In the beginning, I will introduce a graph, and this will give you a little bit of comfort when you are ready to solve vector problems and you do not have a graph. So you will at least have an idea what it looks like. So let us get started. In our first example, we have two vectors, OA and AB, and we will make a note of those immediately. So we have OA as indicated in a column vector format. OA is equal to 2, 3, and we have the vector AB, and that is equal to -1 and 2. So I know you all have had some experience with coordinate geometry. So let us link our knowledge of coordinate geometry with an understanding of what 2, 3 means in a column vector format. It is simply referring to your coordinate geometry system of signs where the positive x direction is to your right, the positive y direction is up, the negative y direction is down, and the negative x direction is to your left. So OA, the vector, means +2 to the right and +3 upwards. So whenever we see an O as the first letter in the vector notation, we know that means it is starting at the origin. So let us make that point here. And this is O for the origin. So now we are going to graphically identify where point A is. Point A is 2 units to the right, 3 units upwards. So we'll write 1, 2, 3. And here we have point A. So all we need now is to draw a line which represents a vector between O and A. Now, before we do anything else, we need to do something extremely important, and we're going to be doing this throughout this exercise, and that is whenever we draw a line to represent a vector, the next thing we need to do is to put an arrow on that line indicating the direction of that vector. So since we are going from O to A in the direction of A, we'll just put an arrow to indicate this on our graph. So there we have it, the first vector OA. Next, we need to draw the vector going from A to B, and that vector has the elements -1, the x direction, and +2 in the y direction. This vector starts from point A. So starting at A, we are going to move 1 position to the left because that is -1 in the x direction, and 2 units up. So let's count 1 in the negative x direction and 2 upwards. So this is our point B. So let's go ahead and complete that. Once again, once we have drawn the vector AB, we will indicate its direction with an arrow. So let's proceed to do that. So this is our vector AB. So now that we have drawn 2 vectors, let us look what else the question is asking us to do. So here we're asked to find the vector OB. So let's draw the vector and then identify its size. O to B is simply the line going from O to B. Okay, and now we have our first 3 vectors drawn, and we can see on the graph a good representation of how we should view the vector going forward. They're simply lines between 2 points, and that is how we're going to treat them. So let's identify OB with its notation, OB, and we need to identify now the size of OB. So let's write the vector going from O to B is equal to, and we'll use the same column vector format. So it's the x component and the y component of the vector. So once again, the column vector notation is identifying the movement in the x direction for the vector, or the x component of the vector, and movement in the y direction, also called the y component of the vector. So let's just read directly from the graph. X is equal to 1, y is equal to 5. Therefore, we'll write as 1, 5. Question 1 is also asking us to identify this vector. What is it called? Well, we said in lesson 1 that if a vector starts at the origin, it begins with an O, that vector is called a position vector. So we write OB is a position vector. Once again, if you are having some difficulty following us, I would strongly recommend that you go back and review lesson number 1. Okay, so question number 2 is asking us to find a vector OC given that the vector from B to C is -3, -2. So what it's asking us to do is to identify the point C and then find the vector from the origin to C. How do we find C? Well, we start at point B and we move 3 units in the negative x direction and 2 units down, or the negative y direction. So let's write again. BC equal to 3 units, the negative x direction, and 2 units in the negative y direction. It's shown here. So let's identify C on the graph. So we start at B and we move towards the left 3 units. So that's 1, 2, 3. Then we move down 2 units. That's 1, 2. So our point C is located here. The vector BC we will now draw, which is a straight line between the points B and C. There we have our vector, and we need to develop the discipline from now of drawing the line and immediately following that up with the direction of the vector BC, and we use an arrow to indicate the direction. So we now have 4 vectors drawn. We need to draw the vector from O to C because that is what we're asked to find. So let's draw that one quickly. Vector going from O to C, which is simply the line going from O to C, or the vector OC. And once we do that, we indicate the direction of that vector with an arrow and label that vector. Okay, I think we're making progress so far. Moving around the graph from one point to another point is simply the definition of what the vector is in terms of its x movement and its y movement. So let us move on to part 3 of the question. And in part 3, it says, find the vector BD given that the coordinates of D are -3 and -3. So let us identify that point D. So we go down -3, -3. So the point D is here. BD, the vector, is going from B to D. So let us construct that quickly. Let's draw that line. So we have the vector B going to D, which is the vector BD. Let's put an arrow to indicate our direction. So to get the size of the vector going from B to D, we simply count starting from B. So from B, it's going to the left. So it is 1, 2, 3, 4 units to the left. So we could write BD. We know that the x component is -4. Let's get the y component. That will be 1, 2, 3, 4, 5, 6, 7, 8. So it is -4 and -8 because we are going down. So the size of the vector is BD, and the direction, of course, is already noted using an arrow. So that is part 3. Let's look at part 4 of the question. Part 4 of the question says, if M is the midpoint of BD, what are the coordinates of M? In this case, from B to M is the halfway point along that vector. So let's write a new vector B to M, and we say this is halfway, or the halfway point of the vector BD. It's just half the length of the line, and the line is BD, which is used to represent the vector. So the midpoint is halfway along that line. So if BM is half of BD, we could write BD is -4, -8. So BM would be equal to -2, -4. The value for BM, let's rewrite it down here. So that's our value for BM. So we can find the point M simply by finding the vector BM, which is -2, -4, starting from B going towards M. So at B, we go -2, which is 1, 2 units to the left. and then 4 units down. So that's 1, 2, 3, 4. So we have identified our point M, and we can read from the graph that the coordinates of M are -1 and 1. So this is a graphical approach to doing vectors. And the idea here was just to get you to see what the vectors look like on a graph. When we don't have a graph to rely on, we will need to make a sketch, and this will give us an idea what the vectors look like. Let us go to exercise number 2 and redo this problem and see what it looks like. Okay, so we are at exercise number 2, and this is simply a repeat of exercise number 1, where we did a graphic solution to a vector problem. Here we are going to solve the problem without a graph, which means this is typically what you may encounter, and we need to know how to add the vectors, subtract the vectors, and maybe multiply the vectors by a constant. Very simple, straightforward stuff. It is just how to do it, and this is what we're going to demonstrate now. So we're going to repeat the exercise. So let's start with what we are given. So in the first instance, we're given OA, the vector OA, as equal to 2, 3, and the vector AB is equal to -1, 2. So these are the first two vectors we're given, and we're asked to find the vector OB. So OB is the vector starting at the origin and going to B. So where is the origin? Since we don't have a graph, let's create an origin. Let's call this point O, and then from O to A, we would go 2 units in the positive X direction and 3 units in the positive Y direction. So A would be somewhere around here. So let's draw the vector OA, and as usual, we're going to put an arrow to indicate that the direction is from O to A. Remember, the vector is simply a line connecting 2 points. If you do not make it any more complicated than that, you will be fine. So we now have OA, the first vector. Let us draw the vector AB. AB starts at A. It moves 1 place to the left and 2 places up, so it's around here somewhere. B is somewhere here. Let us connect the line AB and identify its direction with an arrow. So this is our vector AB. So we're asked in question number 1 to find the vector OB, which is the line connecting O to B. So let's just imagine that this is what we're being asked to find, and let's just label it O to B. We know it's going to be going in this direction. So how do we find that line? Well, here is an approach I would like you to take. You may have used it before. I am proposing that you try to understand it. And why? Because most of my students have found this to be the easiest way to do any type of vector problems without having to memorize the formula. So here's the approach. Since the vector OB is a line going from O to B, then any path or any road that I can take to get from O to B should be equivalent to the vector OB. So what I'm noting immediately is that if I look at where I'm going, which is from O to B, I start at O and I realized I could walk along the path OA, and then I could then walk along the path from A to B. I would get there. So I could write that as OA, first part of my journey, plus AB, second part of my journey, and that should be the equivalent of the vector OB. So let us identify what these two vectors are, and yes, we have values for them. OA is equal to 2, 3, and AB is equal to -1, 2. So if I add those two, that's 2 minus 1 is 1, 3 plus 2 is 5, and I have OB, then the vector is equal to 1, 5. That is the value of OB, and we can write it here because we will need to use that result a little later. So that's the first question. If the vector starts at the origin, it is called a position vector. So we can write OB is a position vector. Second part of the question is asking us to find the vector going from O to C. So we're given that BC is equal to -3, -2, which means that if we are at B to get to C, we would move 3 places in this direction and 2 places down. C would be somewhere here. The vector BC would be the line connecting those 2 points. It's labeled. It's going from B to C. So notice that we are doing something similar to what we did using the graphical approach, but we're not using a graph. We're just using a sketch. So we have a good idea of where the vectors are, where their points are, what it looks like. So we can now find OC, which is our objective, which is the vector going from O to C. So let's just connect the line going from O to C and identify it. So now that I have OC, how do I find the value or the size of that vector? I'm going to use the same technique I used earlier. I want to find the vector OC, so I'm at O, and I need to get to C. Well, if you notice, I have more than one path that I could take to get to C. I could walk along from O to A, then I walk along from A to B, then I walk along B to C, and I could say OC must be equal to the vector sum of going from O to A plus A to B plus B to C. I could say that because I'm walking along each segment of that journey from O to C. So I could do that, but I'm seeing another path. We could go from O to B, which is this way, and then go from B to C. So I could take this path as well. In both cases, I'm starting at O and I'm ending at C. So let us write the second path that we see together. So O to C, we could also write as O to B plus B to C. Now, this is clearly the shorter path. And since you don't have the luxury of time in your exam, I'm proposing that you always take the shortest path from your starting point to your destination. So in this case, I'll write pictorially OB, which is 1, 5. I have the value of these vectors, plus BC, which is -3, -2. So I could write OC as being equal to 1 minus 3 is minus 2. 5 minus 2 is 3. So I could write then that OC we found to be equal to -2 and 3. So now we go to part 3 of our question, and we're asked to find the vector BD, given that the coordinates of D are -3 and -3. So we're given the coordinates of D as D at -3, -3. So on our sketch, we would imagine that it's 3 units displaced to the left, 3 units down, so D would be somewhere around here. And note something immediately. Once you are given the coordinates of a point, you also immediately know its position vector. The values are the same. So we could immediately draw the line from O to D. So we put our arrow, we describe the vector. Oh, that's not what we are asked to find. We're asked to find the vector going from B to D. So here's the line BD and the vector, which we know to be the line going from B to D with a direction. So I'll just put the direction there, label the vector B to D. So now that we have labeled the vector B to D, we need to find its value, its size, its magnitude, or in this case, its length. So we are at point B and we want to get to point D. There are several ways to do that. We could go from B to A to O, O to D. That would get us there. But it is not the shortest path. The shortest path is going from B to O in that direction, and then from O to D that direction. we could write vectorially that to get from B to D, we can take the path along B to O, then take the path from O to D. That should get us there. That should give us the equivalent results for BD. So let us find these vectors. We already have OD. Do we have OD? Yes, here it is. So we have plus OD, -3, -3. But do we have BO? Well, yes and no. Why am I saying this? Because we have the vector OB, and what we want is the vector BO, the vector going in the opposite direction. And if you recall what we did in lesson 1, if you want to change the direction of a vector, multiply the vector by -1. So what we can say here immediately is that BO is equal to the negative of OB. And we already have a value for OB. So all we need to do is reverse the direction of OB, and we can apply to this equation. So we could write this equal to negative OB. Okay, so now that we have that, we can simply write as the negative of OB, which is 1, 5, and we're adding that to -3, -3. Now it may be convenient for us to rearrange, not transpose now, just simply rearrange this equation so our positive vector is on our left and our negative vector is on our right. For example, if I have -x plus y, I may want to rewrite as y minus x. I haven't done anything. I've just rearranged for the positive variable to be on my left and negative on my right. Because this is how we think. Well, most of us anyway. So I'm going to put OB on the right. So I'm going to end up with -3, -3 minus 1, 5. -3, -1 is equal to -4. -3, -5 is equal to -8. So BD, vector BD equal to -4, -8. So the only thing I did here which might cause a little pause is that I reversed the direction of a vector because I was planning to walk in a direction that was opposite to how the vector was defined. The vector was OB. OB was going from O to B, and I wanted to walk from B to O. So I had to reverse that vector. Bear that in mind. Okay, so let us look at the last part of this question, which is part 4, which reads, if M is the midpoint of BD, what are the coordinates of M? Now, whenever you're asked to find the coordinates of a point, always think about finding first its position vector. And here's why. If you know the coordinates of a point, then you also know the position vector because they have the same values. For example, OB is a position vector with values 1, 5, and therefore we could state immediately that B, the point, has coordinates 1, 5. So if I know the position vector, I know the coordinates, and if I know the coordinates, I could also use that to determine the position vector. So in this case, we're asked to find the coordinates of M. So let us first find its position vector. So M is the midpoint of BD, so let's label that here. So let's assume that M is here. So we wish to find the position vector of M in order to get the coordinates of M. So let's identify the position vector, OM. So let's define OM is the position vector of point M. So let us proceed to find the position vector. So we will use a familiar technique to find the value of OM. We are at O and we wish to get to point M. So we could go from O to B in this direction and then B down to M in this direction. So we could write vectorially OM is equal to OB plus BM. So do we have values for these vectors? Okay, so OB is 1, 5 and BM we need to determine. Now note we're given that M is the midpoint of the line BD, and therefore we could write that BM must then be equal to half of the length, which is BD. And since we have a value for BD, this is BD, we could write that is half of -4, -8, which is equal to -2, -4. So we now have a value for BM being equal to -2, -4. We could put that here, and we would arrive at OM being equal to 1 minus 2 be equal to -1. 5 minus 4 is +1. So the position vector of point M is -1, 1, and therefore the coordinates of point M extracted immediately because the values are the same are -1, 1. Okay, so this is the end of lesson number 2. The final lesson is lesson number 3, and this is where we solve vector problems by applying vector techniques to geometric shapes. See you there.